What if the biggest breakthrough in artificial intelligence isn't about making computers smarter, but about understanding the precise limits of how they learn? We often assume that faster algorithms automatically lead to better outcomes. Yet new research suggests the true key to our future lies in a delicate balance between computational speed and the values we embed within these systems. Welcome to a deep dive into two groundbreaking studies that are reshaping how we build the technology of tomorrow. Today, we are exploring the hidden mechanics of machine learning optimization and the profound philosophical questions surrounding the rise of superintelligence. You will discover why extending the efficiency of our algorithms is just as critical as ensuring they align with human values. Stay until the end, because the connection between these two seemingly distinct fields reveals a unified path forward for responsible innovation. For decades, the race to build better artificial intelligence has been driven by a singular focus: raw speed and performance. Engineers have tirelessly optimized code to process data faster, assuming that sheer computational power is the ultimate metric of success. However, this relentless pursuit has created a blind spot. We have become so obsessed with how quickly a model can converge on a solution that we often overlook the structural trade-offs governing that process. Furthermore, in our rush to achieve technical dominance, we have rarely paused to ask whether the intelligence we are creating actually understands us. The problem is not merely a lack of processing power. It is a dual challenge of inefficient resource usage in complex training environments and the growing existential risk of creating powerful systems that do not share our core values. Recent breakthroughs have finally illuminated these hidden dimensions of AI development. On the mechanical side, a new analysis of stochastic momentum methods has overturned long-held assumptions about algorithmic efficiency. Researchers discovered that, while momentum does not universally accelerate the convergence of stochastic gradient descent, it performs a different, equally vital function. Imagine training a model as navigating a vast, foggy landscape. Previous theories suggested momentum was like a turbocharger that made the car go faster everywhere. This new research proves that momentum is actually more like an extended fuel tank. It allows the vehicle to travel further into the unknown without stopping to refuel, effectively extending the window where large batch training remains efficient by a factor of the square root of the condition number. This means we can process massive datasets with significantly reduced serial runtime, optimizing hardware usage without sacrificing accuracy. At the same time, a parallel study on the nature of AI has shifted the conversation from technical metrics to existential survival. This work frames the development of artificial intelligence as a collision between rapid capability growth and the potential for catastrophe. The researchers argue that the primary danger is not technical failure or hardware malfunction, but the emergence of a superintelligence that is misaligned with human values. Think of it this way: giving a child a sharp knife is not dangerous because the knife is sharp, but because the child does not yet understand how to use it safely. The study identifies value misalignment as the core driver of risk, suggesting that a superintelligent system acting without our ethical framework could pose a threat to our very existence. The implications of these findings are staggering for both the scientific community and society at all. For researchers and engineers, the insights on momentum provide a practical blueprint for the next generation of machine learning models. We now have a theoretical basis to select batch sizes and momentum parameters that maximize our finite computing resources, ensuring that large-scale training projects in fields like genomics and climate modeling are sustainable. We can stop wasting cycles on inefficient small-batch processing, and instead leverage these extended efficiency windows to solve problems previously deemed too computationally expensive. On a societal level, the reframing of AI as an existential dilemma serves as a crucial check for policymakers and ethicists. It urges us to move beyond short-term benchmarks and performance charts to focus on the long-term stability of autonomous systems by identifying misalignment with human values as the central risk. This perspective encourages the development of governance structures that ensure AI remains a beneficial partner rather than an existential threat. It calls for a future where our technological growth is inextricably linked with our ethical evolution, ensuring that the superintelligence we create acts as a guardian of humanity rather its successor. In summary, today's research clarifies that the future of AI depends on mastering both the mechanical limits of our algorithms and the philosophical alignment of our creations. The discovery that momentum extends efficient training windows allows us to build faster, more resource-conscious models, while the recognition of value misalignment as a primary risk demands that we prioritize safety and ethics above raw performance. As we stand on the brink of this new era, let us commit to building systems that are not only computationally powerful, but also deeply aligned with the human spirit. Like, subscribe, and comment your thoughts on whether we are ready to align our values with the superintelligence we are creating. Next time, we will explore how these principles apply to the next wave of quantum computing, so stay tuned.